In this video, we're going to have the product rule. Recall that in the sum rule, the derivative of a sum is a sum of derivatives. And similarly, the derivative of a difference is a difference of derivatives. For the product rule, we are going to have a different story. Note that if we consider a differentiable function, that means its derivative exists. So assume that f and g are differentiable functions. So the derivative with respect to x of f of x times g of x is f of x times the derivative with respect to x of the g of x plus the g of x times the derivative with respect to x of the f of x. If you think that was mouthful, we can instead use some mnemonics. So we can use first the second plus second the first. Again, the derivative of the product fg is f times the derivative of g plus g times the derivative of f. So let's apply the product rule to find the derivative of x squared times x cubed. So we are going to have x squared times the derivative of x cubed plus x cubed times the derivative of x squared. So by power rule, the derivative of x cubed is 3x squared. And the derivative of x squared is 2x. And multiplying these two will result to 3x to the 4, while the x cubed times 2x will result to 2x to the 4. And summing them up, you're going to have 5x to the 4. On the other hand, if we are going to multiply directly the x squared and x cubed, you're going to have x to the 5, and the derivative of x to the 5 is 5x to the 4. So here we are given of p of x equals x minus 1 times 3x minus 2. So before taking the derivative, we have the option to expand the p of x. By FOIL method, we are going to have 3x squared minus 5x plus 2. So by applying appropriate basic techniques of differentiation, p prime of x is then equal to 6x minus 5. In the case of applying the product rule, we are going to get p prime of x equals x minus 1 times the derivative of 3x minus 2 plus 3x minus 2 times the derivative of x minus 1. So the derivative of 3x minus 2 is 3, while the derivative of x minus 1 is 1. So algebraically, simplifying also results to 6x minus 5. So in this example, we are given of a curve described by the equation y equals 2x plus 1 times 2x squared minus x minus 1. Now let's find y prime. So by applying the product rule, we're going to have first the second plus second the first. So we're going to have 2x plus 1 times 4x minus 1 plus 2x squared minus x minus 1 times 2. So at this point, you have the option not to simplify this one. However, if you're going to simplify this, you will result to 12x squared minus 3. For this part, we're going to find the equation of the line tangent to the curve at the point on which x is equal to 1. So here, as presented, we need to first find the point of tangency. So since we have x equals 1, we plug in this value into the given equation. And this results to having 0. And from part A, evaluating y prime at x equals 1, you are going to get 9. This means 9 is the slope of the line tangent to the curve at the point 1, 0. So since we have this point and the slope, so we can use the point slope formula to find for the equation of the tangent line. So we plug in here the value 0 and the value 1. So simplifying, we're going to get y equals 9x minus 9. For this part, we are going to find all possible points on the given curve having horizontal tangent line. So we will use the idea that if a line is horizontal, its slope is 0. So as mentioned in part A, if we simplify the y prime, it's supposedly 12x squared minus 3. So by setting y prime equals 0, we're going to get 12x squared minus 3 equals 0. So x squared is equal to 1/4. And taking square roots of both sides, you're going to get x equals 1/2 and x equals -1/2. And substituting these values into y, 1/2 yields -2, while -1/2 yields 0. So tangent lines to the curve at these points are going to be horizontal. So graphing this curve on the Cartesian plane, you will see here that at -1/2, 0, the tangent line is horizontal. And at the point 1/2, -2, the tangent line is also horizontal.